Here's a real quick tutorial on balancing redox reactions. And summarizing the steps, first thing you got to do is write the two half reactions, an oxidation half reaction and a reduction half reaction. Remember that the oxidation is loss, so the electrons should be on the right, and reduction is gain, so those electrons should be on the left side of the arrow. After you've got the half reactions, balance each half reaction by mass. So you want to balance all of the elements except for oxygen and hydrogen, leaving those for next. Finally, on the side that's of the reaction that's lacking oxygen or short on oxygen, you can add water to that side. And then that usually leaves an imbalance of hydrogen ions, and what you could do then is just add protons to the side that's short on hydrogen ions. Now that's if in an acidic environment. If it's in a basic environment, then you're going to want to neutralize each of the hydrogen ion with an equal number of hydroxides. But remember, if you add something to one side, you've got to add it to the other. So if you add 8 hydroxide to the left, you've got to add 8 hydroxide to the right. Now that you've got the mass balanced, now balance the charge. So you want the sum of all of the charges on each side of the half reaction to be equal to one another. And to do that, you can add electrons, and you want to add electrons to the side that with the more positive total charge. Now after the two half reactions are balanced, you're going to want to balance the electrons between the two reactions so that the extent of each half reaction is equal to one another. And finally, add the half reactions, and then if necessary, simplify it so that everything is in the lowest whole number ratios. Alright, let's start off balancing a reaction in an acidic environment. Here we're going to take this hypophosphorous acid in the presence of dichromate to produce phosphoric acid and chromium 3 ions. We'll split it up into two half reactions. We'll say that H3PO2 goes to form H3PO4. And we see on this reaction, on the left-hand side, we are short 2 oxygen. So what we'll do is we will add the oxygen in the form of water to water to make up for those 2 missing oxygen. And now that gives us an excess of hydrogen, and so we will balance that by adding 4 protons to the right. So now we've got a total of 7 hydrogen on each side. And then we've got 4 oxygen on each side and a phosphorus. So now all we have left to do is to balance the charge. And if we sum up the charges on the left, we get a total charge of 0. On the right, we get a total charge of positive 4. So that means the right side is more positive. We're going to add 4 electrons. Then the second half reaction, we've got the dichromate, Cr2O7 2- goes to Cr3+, and we'll balance the chromium, so we're going to need 2 of the chromium 3 ions. And now we're short oxygen, so we will add 7 water molecules to the right, and that's going to make us, we will need to now add 14 protons to the left to balance out that hydrogen. And now mass is balanced, but charge isn't. So if we look at this, we've got 14 positive and 2 negative, a total of plus 12. And here we've got 2 plus 3s and a neutral, so at plus 6. The difference is 6 electrons different, and we put that on the more positive side, so we're going to add 6 electrons to the left. Now, in terms of balancing the extent of each half reaction, the least common multiple between 4 and 6 is 12, so we'll multiply this whole reaction by 3 and this whole reaction by 2. That gives us 12 electrons, 28 hydrogen, 2 dichromates, 4 chromium, 14 water. Here we're going to have 12 electrons, 12 protons, 3 of these, 3 of these, and 6 waters. Alright, so now let's try and simplify things before we sum them up. If we've got something similar on opposite sides of the equation, so for instance we've got 6 water over here, 14 over here, we can cross out those 6, and 14 minus the 6, so we'll subtract 6 from both sides. That's going to leave us with 8 electrons, 8 water molecules in total. Our 12 electrons will balance out, will cancel each other out. Sorry, this is getting a little bit messy. We've got 12 protons over here, 28 over here. That's going to leave us with 16 protons there. And I think we've simplified it as much as we can, so now we just sum up the two reactions. Should be left with something like 16 protons plus 3 H. Let's balance in under basic conditions, and to do that we will start with the half reaction MnO4 our permanganate into the MnO2, the manganese 4 oxide. And we'll see on the right hand side of the equation we're short by 2 oxygen, so we will add 2 water. And now that leaves us with an excess of hydrogen, which we'll add to the left for hydrogen ions. Because we're in basic conditions, we're going to have to neutralize that excess hydrogen ion with 4 hydroxides. And if we add the hydroxide to one side, we have to add it to the other. Now, the 4 hydroxide and 4 hydrogen ions makes 4 water, and neutralization. Think of it in terms of neutralization. And now we can simplify this. If we've got 2 water on the right, 4 on the left, that leaves us with 2. In fact, I'm just going to erase that. 2 water. Now we can balance charge. On the left we've got a -1, on the right we've got a -4, so we will have to add 3 electrons to the left. Now the oxalate C2O4 2- to form CO2. Balance the mass, 2 carbon on the left, 2 carbon on the right, 4 oxygen on the left, 4 oxygen on the right. Now balance the charge, 2 electrons. Now, least common whole number between 2 and 3 is 6, so we will multiply our top reaction by 2. Oh, probably can't see that. That went off the screen. We will multiply the top reaction by 2 and the bottom reaction by 3. That's going to leave us with 6 oxalate. Oops, excuse me. 3 oxalate, 6 carbon dioxide, and 6 electrons. Multiplying the top reaction, that's 6 electrons, 4 water, 2 permanganate, 2 manganese 4 oxide, and 8 hydroxide. Now in terms of simplifying, we can get rid of the 6 electrons and now add it up. We're left with 4 water plus 2 MnO4- plus 3 oxalate C2O4 2- to produce 2 Oops, that's wrong. That would be a 6. CO2 plus 2 MnO2. And is there anything else that's left? 8 hydroxide. Now, if we did everything right, our charge and mass should be balanced. And I hope that helps.